Hello students. So hope you people are doing well at home. So studying thoroughly. Already competitive classes are started, and in the previous session we have discussed about P01 topic. Already the material is been sent to you people like a PDF file. Thereafter again the same 30 questions we have discussed in the class. So today we are going to continue that. So today's topic, that is P02. So P01, which in all concepts we have discussed there is units and measurement. Of course it is first and second chapter. First chapter is not that important, that is why we have excluded that one. Few of the questions might have included there. And second chapter, that is units and measurement, we discussed, and there we have discussed around 30 questions and in detail. Hope you people are understanding all those concepts. So today what we do is P02 we are going for. P02 means it's actually the combination of chapters like motion in one dimension as well as motion in a plane. Here also 30 questions. Already you have got the PDF file of 30 questions. Before that, before the video classes, we already sent you the synopsis part, detailed synopsis, all those things. Again 30 more questions for practice. But right now what we do is, again we are discussing some new questions, higher level and all. So let us continue today, okay? So already you got the 30 questions. You might have seen the questions, which includes the chapters like motion in one dimension and motion in a plane. And what I suggest you people is, already I told you people in the previous video online class, maintain a separate notebook where write down all those 30 questions, leave some space, try solving that. If you are not able to solve me, just leave space. When we discuss here, you can note down that. By the end of this video session, that means online video classes, you will be getting from each module 20 questions. Means imagine 20 modules are there. So each module 30 questions, total 20 modules. So 600 questions from physics only you are going to get. Similarly, chemistry, maths for JE as well. And along with that, biology, 50 questions from each module. Just imagine how many questions you are going to get. That is why it is very, very useful for you people. So utilize it for the maximum. So let us continue today. So the question paper is already sent to you people. So let me go through the questions as well as the answers. Then let us begin now. So motion in one dimension, vectors, motion in a plane. So these three topics will be included in that particularly the module paper P02. So first question I am going for now. So let me read the question. So question number 1. Today's paper P02. The question is, a particle moving in a straight line from A to B for the first half of the time with the uniform velocity v1, for the next half of the time with uniform velocity v2, the average velocity of the particle is. So it is something like average, okay, average speed or average velocity concept. And let me just go through with the basic diagram of this. Particle moving in a straight line from A to B is given. So I will take, this is point A on point B, okay. Next, for the first half of the time they have given. For first half of the time it is mentioned. So half of the time means, let me take T by 2 also you can take, no problem. Next they have mentioned with velocity v1. So it is moving like this from A to B half of the time. Total time t if you take from A to B T by 2 with velocity v1. Uniform velocity. Okay. For next half of the time it is mentioned, it's moving with velocity v2. Again T by 2 I have taken. So this is a basic diagram I have, okay, mentioned. Now whether it is mentioned how much distance it is already covered. Separate, what is that? Velocity. Same time which is being split into half. If it is 10 means again it should be 10. If it is 5, something like that, okay. Though time is same, velocities are different. So distance traveled in these two intervals, A to B as well as B to C, is not same. So now what I do, I will take average velocity is equal to, velocity equal to what? Distance by time. So whether distance traveled is same in both the intervals? No, I don't know. So I will go for A plus A to B now. That is, I will take D1. Next, B to C, whether you know, whether it's D1 same? No. Some other distance, because velocity has changed for the same regular time interval. What about time? Total time taken. Total distance traveled by total time taken, or total displacement by time taken. Okay, like that we can say, because it is unidirectional. Displacement and distance is one and the same. Next, total time. This half plus this half, totally I will be taking total time T. Now, let us check the options. Whether options is containing such options? No. Out of 4 options here, no options are having such kind of equation. So I will go for some substitutions. What is that substitution I can go for? I will go for the basic. Okay, what is that? Velocity equal to distance or displacement by time. I can substitute because D value I don't know. So I will just make a small rearrangement. D is equal to what? D is equal to V into T, correct? So D is equal to V into T I can take. Next, whether here it is applicable directly V into T? No, because time is slightly different here. It is for total time, okay? So what I can write here? D1 I can write in the form of velocity into time. So I can write, what is the velocity for first distance traveled? It is V1. What is the time taken? This is T by 2. Plus, what next? Second distance traveled. What is the second distance traveled? With velocity V2 at time T by 2, right? So it is V2 T by 2. So what is the total time taken here? This is T. So next, you can evaluate, you can substitute. Soon after the substitutions, what you get is V1 plus V2 divided by 2. So hope this is clear for you people. I repeat once again, they have asked regular time interval. When time interval is split into, okay, equal halves. Thereafter, they are asking you what is the average velocity. We simply can't directly write this total distance by time because we have to check the options here, which are the options which is suitable for. So it's like a derivation. We are just substituting some known equations. So some small rearrangements we have done here. So that rearrangement you can see like this, we have got the answer now. So now I will go for the next question. Question number 2. So question number 1, hope it is clear for you people. Next, question number 2. Let me read the question. A particle moves from A to B for the first half of a distance with uniform speed V1. Almost similar kind of questions. I have framed these questions because these are closely related, but some parameters are different. That is why, kind of interesting question itself. Look at there. A particle moves from A to B for the first half of the distance with uniform speed V1 and the next half of the distance with the uniform speed V2. The average speed of the particle is. So the question looks almost similar to that of the previous one. First question, let me take the point A here and let me take a point B, position B, and let me take a point C here. Next, the particle moves from here to here, okay, A to B, first half of the distance. That means they have divided the total distance traveled into equal halves. So regular interval log, that means regular interval of distance or displacement here, correct? And it is given that with the uniform speed V1 here from A to B, and next here from B to C it is moving with uniform speed V2. Now what is actually identical here? Identical thing is what? Identical thing is displacement here, or the distance traveled, equal interval it has taken. Whether time is same now? No, because speed has varied. Total distance traveled is equal in both the intervals. And velocity is different. That means time taken also will be different. So now what I do, I will go for the average velocity, or here speed. Average speed is equal to What is that? Total distance traveled. D by 2 plus D by 2. What is that? I can just write like this. But whether you know what's the total time taken, I don't know. So I will write total time. T you can write. But instead from A to B, B to C, the two intervals are there. So I will take T1 plus T2. So T1 plus T2 I will take. So when we take in this particular way, you can see previous equation here, how we have substituted, for what we have substituted in order to get the final answer. Now you can make out for which of the numerator or denominator we are supposed to substitute. Of course it is for which one? It is for time. So general expression V is equal to, like this I can take. So time is equal to distance by velocity, like this I can conclude. Then I will substitute over here. So V average is equal to distance divided by time T1 for what here, okay? T1 with velocity V1, distance traveled is D by 2. So this is D by 2 divided by V1 plus next half of the distance D by 2 with what velocity? It is V2. So now what you are supposed to do, just go on substituting. Soon after substitutions, what you get is, yes, by taking the LCM, all those things, you will be getting 2 V1. Substitute, okay, clearly you will be getting the answer V1 plus V2. So this is all about the question number 2. I think it is clear for you people how to substitute. First question, second questions are closely related to one another. So hope it is clear. So let me go for the third question. It's almost similar kind itself, but it has got values here. It is not something like derivation kind of numerical. It has got values, okay? Physical quantities has got values. So let me go for the third questions. The third question is, one car moving on a straight road covers 1/3 of the distance with 20 km per hour and rest of the distance with 60 km per hour. The average speed is, whether the distance is equally distributed here, no, 1/3 and remaining like that. So let us draw the diagram, okay? So I will again take A, B, C slightly it is for the distance, because 1/3 of the distance is, so 1/3 of the distance, that means D by 3 is covered from A to B. Look at there, one car is moving on a straight road, covers 1/3 of the distance with 20 km per hour. What is the speed with which is going? 20 km per hour. Next, what is that? And the rest with the 60 km per hour. Here it is going with 60 km per hour. And now A to B, B to C. And you know, from A to B how much distance is actually covered? That is D by 3. That means 1/3. It is mentioned there. 1/3 of the distance is covered. That means remaining is how much here? Remaining will be 2D by 3 distance. Now what I do? Whether time we know, velocity mentioned, distance also we know. So average, what is there required? Average speed is. So average speed is equal to what? Total distance traveled, D by 3 plus 2D by 3, total D itself. And next, what is here? Total time taken, T1 plus T2. Values are mentioned in the question? No. So D, what are the substitutions I can get for T1 and T2? You can remember here, look at there. Yes, like this. So what is that? D by 3. 1/3 of the distance A to B. And what is the velocity V1? It is mentioned here. Our speed, what is that? It is 20. Next, remaining distance 2D by 3. Okay. Hope you people are understanding this step, what I have mentioned here. It's almost similar to the previous one, but it includes numerical values. Next, with what speed it is going here after B to C? That is, from B to C it's going with the speed of 60. And now by taking the proper LCM and cancelling the term D, finally you have to get, what is the value? You will be getting the value 36 kilometer per hour. So 36 kilometer per hour is the answer. Okay, so look at there steps I have taken. All these three are almost similar. Slightly it is different from one to another. So A to B it has to travel, B to C it has to travel with respective speeds is mentioned, and average speed. Simply or blindly don't take the equations directly for all kind of questions. We have to do some substitutions like this. So it depends on the question how it is asked. Okay, and then like this we have taken, and finally the numerical value we got, and the value is 36 kilometer per hour. So this is all about the question number 3. Next, let us continue. Question number 4. Question number 4. Let us see what is there in question number 4. Let me read the question. Question number 4. In that, question is like this. The ratio of displacement in n seconds and in nth second for a particle moving in a straight line under constant acceleration starting from rest is. So it is something like a fixed formulas are there, like equations of motion you people know. That is V is equal to U plus AT. Thereafter S is equal to UT plus half AT square, and the third one is V square equal to U square plus 2AS. But distance travelled by a particle or a body in nth second, if it is asked me, separate formula is there. What is that formula? You might be knowing. So distance travelled in nth second is given by UT plus half 2n minus 1. Distance travelled in nth second. Okay, I will take nth, yes, nth. Okay. Now, whether the question is about only nth second, no. It is asked to find ratio of displacement in n seconds and nth second it is asked. What is displacement in n seconds? Is there any alternate formula is there? Okay, we'll be having. So, ut plus half at square. In the place of t, what I write? an square. Why I am writing n square? You understood, right? Because in the question it is mentioned n seconds. Displacement in n seconds. Distance in the displacement in n second times nth second for a particle, like that it is asked. And starting from rest it is mentioned at the end of the question. Okay, starting from rest means initial velocity. What is that? U will be equal to 0. So what I can write here? Yes, n I will write. Distance or displacement in n seconds is, this term becomes 0. So this is half an square, equation number 1. Okay. Next, displacement in nth second. For that separate formula is there. This is actually a regular formula we have used here. For nth second means something different. And what is that? Half into 2n minus equation number 2. Now what they are asking is, we require to find out the ratio of these two. So what is that ratio? Sn divided by Snth is equal to, okay, here half A is there, like this, half A into 2n minus 1, correct? Look at there. In n formula it is half into A into 2n minus 1. Okay, here also A is there. The place of n square, here it is for n second. That is why it is 2n minus 1. So by equating these two, what we can write? Equation 1 divided by equation number 2 gives you what? Remaining thing is n square divided by 2n minus 1. So what is the formula? Separate formula which is used for distance travelled by a particle in nth second. That is given by Snth is equal to ut plus half A into 2n minus 1, where n is the distance travelled in nth second. Okay. Next, distance travelled in n seconds. In the sense, if the time is given 5 seconds, apply the directly. So ut plus half at square. Instead of writing t, I am writing n. Why? Because it is given in intervals. It is substituted. That is why Sn equal like this I have taken. As the question itself says, the object is starting from rest. That is why initial velocity is 0. The questions, according to that, we have written the equation. We have modulated that. So finally, we arrive at this particular answer, and the option is option number D. So answer you can see n square by 2n minus 1. So that is all about the question number 4. Next, question number 5. So let us go for the question number 5. Let me read the question. The question is, a body is moving with uniform acceleration, covers 40 meter in the first 4 seconds, 120 meter in the next 4 seconds. The initial velocity and acceleration are. So question number 5, a body is moving with uniform acceleration, covers 40 meter in the first 4 seconds. Let me take the same almost similar diagram. I will take like this AB. First it covers 40 meters. In how much time? It is 4 seconds. Okay. Next. And 120 meter in the next 4 seconds. That means slightly lengthier diagram I will do. Let me take this. So this is 120 meter in the next 4 seconds. How it is possible? That means the body has to accelerate. Okay. By accelerating, velocity has increased. That is why same 4 seconds it is able to cover how much? 3 times that of the previous one. Now what we do? We will be looking at the substitutions. And one more thing, you can see there the question, the options B and D is almost similar. That is why make the option D as 0 meter per second and 5 meter per second square. Which one? Question number 5. Last option, that is option D, make a small change. 0,5 it should be. That means 0 meter per second velocity and 5 meter per second square is the acceleration, because identical kind of options are there in that questions. That is why. So now what I do? We got the hint. Okay. That means the object is traveling. First interval in 4 seconds covers 40 meter. Next interval 120 meter is able to reach just in the same time 4 seconds. Now what I do? Whether object is starting from rest, a car moving the speed of 40. Yes. And here final velocity or initial velocity is actually mentioned? No. So what we do? Initial velocity we don't know. Acceleration we don't know. But we are able to substitute, right? So let us substitute that one. And now let us see. Body is moving with uniform acceleration to cover 40 meters. So 40 meters it is supposed to cover. That means I will just go for the formula S equal to ut plus half at square formula. Okay, basic formula. How much it has covered? 40 meters equal to initial velocity, you know, I don't know. What about time taken? 4 seconds. So u into 4. Next, half into, do you know acceleration? No. What is time taken? Yes, this is 4 square. So how it can be written now? 40 equal to 4u plus 8a. Equation number 1 I will take. From A to B, how much distance traveled, what and all equation is possible I have done there. Now what I do? From A to C I will take. Okay, so this is A to B. Now A to C I will take. A to C, what is the total distance? From B to C it is 120. Because here total distance I am taking from A to C. So 40 plus 120 it is 160 equal to, what is the initial velocity? Don't know. So u into t, time taken from A to C is 8 seconds, right? Plus half into a, t square, t means total time 8 square. So 160 equal to 8u plus, okay, 32a, equation number 2. So from A to B and then A to C. Hope you understood how to understand that. Okay. So right now you got 2 equations, and what you're supposed to do? Let us equate. Okay. After equating, okay, simple it is. After equating, you're supposed to get u equal to 0 meter per second and acceleration 5 meter per second square. So this is how you are supposed to get the answer. So this is all about the question number 5. So question number 5, hope it is clear for you people. And let me go for the next question. And the question number is 6. Okay. So question number 6, I will continue here, which is almost similar like previous one. Question number 6 says, a car moving with a speed of 40 km per hour can be stopped by applying brakes after at least 2 meter. Okay. That means car is moving with a particular speed. When you apply brake, after traveling extra 2 meters, it is able to stop. What they are doing? They are actually doubling the speed now. Now, what is extra distance it is going to travel before coming to rest? Do you think that again 2 becomes 4? Not like that. It all depends. Some of the equations are supposed to be solved here. So we cannot blindly do like that calculations. We have to check scientifically. Now what I do is I will check how it is possible. The final velocity is, yes, of course you know. So what is that? However, car is coming to rest. Right? Coming to rest means yes. What is that? Retardation. So I will take v square equal to u square minus 2as formula. Hope it is clear for you, because initial velocities we know, they have mentioned there 40 km and 80 kilometers. Okay. So then let me substitute. Final velocity, of course, after coming to rest, 0. Next, u square. That means how much it is? 40 square minus 2 a into how much distance it is travelled. In the first case, it has travelled how much distance? 2as. S means, yes, of course, the value is there, right? So it is 2. Next, in second case, equation number 1 we can take. Second case, what is that? 80. So 80 square minus 2a. What is the distance travelled? We don't know. Let us take D. Question number 2. Now once you start, okay, that is evaluating these two equations, you are going to get what? You are going to get two equations like this. That is 1600 equal to 4a you have to get. Next, 12,000 on substitutions you will be getting, okay, 12,000, it is 800 equals to 4AD. Like this you will get after substitutions, okay. Now what you are supposed to do? Now do the substitutions. So once you do the substitutions, the answer what you are supposed to get is D value will be equal to 8 meter. So answer D is equal to 8 meter. So this is the answer. So we have started with the question number 1, and right now we have finished question number 6. It's all about motion in one dimension concept. So I think these two questions are slightly similar. What we do, we don't have direct data here. That is why we do what? We'll be just using the equations. Equations we will be solving, and by that unknowns can be found out. So this is how we are solving this kind of numericals. So that is about the question number 6. So question number 1, 2, 3, 4, 5, 6. All this we have discussed. And I think you have understood it clearly. Fine.